If we don't know a solution's concentration, we react a second solution of known concentration, called a standard solution, with the first. Based on the stoichiometry of the reaction, we can determine the unknown solution's concentration. This procedure is called a titration, and you can see on the right here, this is often what the setup looks like. We have two burettes, one perhaps filled with acid, another filled with base. We have a double burette clamp right there, all of that attached to a ring stand. The equivalence point of a titration occurs when stoichiometrically equivalent quantities are brought together. This point is identified by using indicators, which are chemicals whose color depends on the pH. A sudden color change indicates the end point of the titration, which coincides closely with the equivalence point and is usually considered to be good enough. You can see in the lower left here, we must have added the indicator phenolphthalein. Phenolphthalein is this pinkish or magenta-like color in basic solution. Let's try an example problem. If 56.0 milliliters of sodium hydroxide neutralize 19.0 milliliters of 0.235 molar nitric acid, find the concentration of the base. You can see the picture here. We've added a certain volume of sodium hydroxide to a known volume of acid, and we've determined that the system is now neutral, and we need to calculate the concentration that the base was. When we're at the equivalence point, when we have added stoichiometrically equivalent amounts of acid and base, this is the statement that holds. The moles of H equal the moles of OH. Related to molarity, you might remember that moles is molarity times volume. Well, then moles of H is molarity of H times the volume of acid. And since in this statement it doesn't really matter what the volume unit is, as long as it's the same on both sides, then we'll be fine. Another way of writing that exact same relation is this way, where the square brackets indicate molarity. This is not two equations, it's one equation. They have exactly the same meaning. Nitric acid has that formula. It's a strong electrolyte. It ionizes 100%. Sodium hydroxide is also a strong electrolyte. It dissociates 100%. We're given the concentration of the nitric acid. We're asked to find the concentration of the base. Let's start with our equation. What we note here is that nitric acid ionizes 100%. So the concentration of H, which is what is asked for in the equation, is 0.235 molar. We're given the volume of acid that we added, 19 milliliters. And now in the equation we need to calculate the concentration of the OH. Because sodium hydroxide is a strong electrolyte, whatever the concentration of the base is, that's going to be the concentration of the OH. So I'm just going to put essentially X there, and the volume of base we added was 56 milliliters. We can then calculate this for the concentration of OH. And by at least thinking this dissociation equation, we know that the concentration of the OH matches the concentration or the molarity of the NaOH. And that turns out to the correct number of sig figs to be 0.0797 molar NaOH.